Okay, the second way we're going to talk about solving systems of equations is by a process called substitution. And it's exactly like it sounds. We're going to take one thing and substitute it in for another. So I relate this to what happens on days that I'm not here. You are not left without an adult or a teacher in the room. Somebody else comes in to take my place. They probably don't look like me. They don't talk like me, but they serve my same purpose in the classroom. And we're going to do that today. The reason we're allowed to do this is because, as we remember, the solution to a system is the single ordered pair that fits them both. That means that this x and this x represent the same number. This y and this y represent the same number. So because of that, I can use them interchangeably. Okay, so if I ever have a variable already by itself, that makes it a lot easier for me. I'm going to start with that. Here I see that I have y by itself. It tells me I don't know a number that y is equal to, but I do know that y is twice whatever x is. I can use that in my favor. So I'm going to come down here to this equation. I'm going to rewrite it. X plus, now instead of writing the letter y, I'm going to put something that can be substituted for y, which in this case is 2x. So x plus y equals 12. I took the y out and I put something that it was congruent to in its place. Okay, now x plus 2x I know is 3x. That was the whole purpose of doing this. Now that I have all x's, I can solve for x equals 12. I know that 3 times 4 is 12, or I can do inverse operations, divide by 3 on both sides. So I know that x is equal to 4. Now, as we set up here, the solution is an ordered pair. So I don't just want an x, I also need to have a y. Well, I was told that y is equal to twice, I was told that y was equal to twice whatever x is. I now know that x is 4. So y is twice 4. That makes y equal to 8. I now have an ordered pair. When x is 4, y is 8. On your own, pause the video, plug it into both equations, make sure it works. All right, and let's move on to number 2. Now, we are used to seeing y by itself. Whenever we're going to graph, we always get y alone so that we can have mx plus b format, slope-intercept form. We are not going to make this hard on ourselves, though. If I'm told what x is, I can substitute for x. I'm not graphing, so I don't necessarily have to have y by itself. Here, I can easily take what x is equal to, and I can substitute it in for any other x. So I'm going to rewrite this equation. In the place of x, I'm going to put 3y minus 1. I still have plus 2y, and it's still equal to 9. Combine like terms, 3y and 2y make 5y's. Still have the minus 1. Everything's still equal to 9. Okay. The opposite of minus 1 is plus 1. If I do it to the left side, I have to balance my equation and do it to the right side. 9 plus 1 is 10. I still have 5y. The opposite of multiplying is dividing, so I can get rid of this by dividing on both sides. If I do that, I have to balance it. I have to divide on the other side. 10 divided by 5 is 2. So now I didn't find x first this time like I did before. I found y first. That's okay. Now that I know what y is, I know how to find x. X is 3 times y minus 1. So that means x is 3 times 2 minus 1. 3 times 2 is 6. Excuse me. And 6 minus 1 is, of course, 5. So when x is 5, y is 2. And there's my answer. Pause the video for a second, plug these in, and make sure that they work for both equations. They can't be just one, it has to be both. And finally, our last example. So again, I have y by itself. That means I can take this, and I can plug it in for y. Now this one we're going to have to make sure we look at. So I have 4x. I was subtracting the variable y. That means that whenever I substitute in for y, all of it has to get subtracted. So I need to make sure I put parentheses around this so that I remember this is all being representative of one variable. Still equals 7. I have to subtract all of this. Okay, so I would go ahead and just distribute everything through. Minus a positive becomes minus, and this becomes plus. So 4x plus a negative 4x, or 4x minus 4x, that cancels. I was subtracting a negative, so I was taking away something that was negative, which means I moved it to the positive. So this leaves me with just 5 equals 7. So it doesn't seem to make very much sense. I think we would all agree 5 is in fact not equal to 7. So let's think about what that means in terms of this equation. If I had written this out, I could have gotten rid of my parentheses by subtracting 4x, subtracting the minus 5 would have given me plus 5. X represents the same number in both of these situations. So what I see here is no matter what I plug in for x, I'm going to plug that same number in here. When I multiply it by 4, this is always, always, always going to cancel. There's not a thing I can plug in for x that's going to be different when I multiply it by 4 one time rather than the second time. So what I see is no matter what I plug in, I'm always going to get wrong. Well, the good thing for us, we know that there's not always a solution. And so in fact, what I can say about this is there is no solution to this system. If I were to get both of these into y-intercept form, you would find that they both have the same slope, which means the lines are parallel. So what you need to do now is pause the video, get y by itself on both of them, and see, prove that. Prove they both have the same slope, and then have a good day.